We want to look at some other similarities to when we used to factor back in chapter 6 when we had some factoring problems. What we can do here, root 3 plus root 7 squared. Well, I usually like just to multiply, write it out. Root 3 plus root 7 times root 3 plus root 7. And just factor it out or FOIL it out. So first term times first term, root 3 times root 3 is a 3. Outer terms gives me a root 21. Inner terms, root 7 times root 3 gives me a root 21. And last terms times last, square root of 7 times the square root of 7 is 7. I can combine my like terms. So I have 10 plus 2 root 21s. And I hope that after you practice these several times, you start to see a similar pattern that you had when you factored binomials. Let's look at another one. Root 7 plus root 3 times negative, or root 7 minus root 3. Do you see anything in this one? It almost looks like it could be a difference of 2 squares. So let's multiply it out and see what happens. Root 7 times root 7, 7. Outer terms, negative root 21. Inner terms, positive root 21. Outer terms, negative 3. So I have 7, take away 3, which is a 4. And the middle terms, negative 21 plus a 21, go away. So I'm just left with a 4. What these two terms are to each other is a term that we call a conjugate. And this is a conjugate pair, where these two terms are identical except the middle sign is off by a negative, or one's a positive, one's a negative. So a general rule sometimes is if you have something like square root of a plus the square root of b times the square root of a minus the square root of b, it is basically the first term squared minus the second term squared, or a minus b will be the result of that particular problem. Well, you can use that shortcut if you want, but I would encourage you to go ahead and multiply it out several times until it starts to become second nature. Then from there you can go ahead and see, oh yeah, okay, I know what it is. It's the difference of 2 squares, or that type of an idea.